Okay, so hi, I'm Dalton. I'm a assistant professor at Cal State San Bernardino in the Department of Math, and I think we'll find a lot of similarities between things we've been talking about today. So the title of this is Are STEM Underrepresented Students Less Motivated in Math and Science? I think that's often I took that as the title because I think that's often what people might think, but I think I show here that there's a lot more nuance, and we've already kind of discussed how that could come up. So my motivation personally is I'm a math teacher, and this is something I hear a whole lot. I'm not a math person. We'll see how important that actually turns out being in my analysis here. So just some background. Internationally, which kinds of students are underrepresented in STEM? Internationally, female students and students from socioeconomically disadvantaged backgrounds are underrepresented in science, technology, engineering, and math. And this has been looked at a lot of different ways in terms of like math and science course taking or getting degrees in STEM or in aspiring to STEM careers, and in many different ways. In the United States in particular, STEM degree earners are disproportionately white or Asian males. And when we dig down more, because we're into like when we disaggregate things, where there's big differences are in engineering and physical and computer and mathematical sciences. So STEM has been defined in a lot of different ways, and it can be different if you like biology has more gender equality in it, and psychology has even more female students in it. So it can really depend on which ones you look at, but we often hear about STEM degrees in particular. I think the ones that if we think about STEM underrepresentation, we should think about the engineering, physical, computer, and math sciences as well, the ones having the biggest disparities. Something that's often looked at is motivational attitudes towards math and science as contributing factors to what influences students to major in STEM. Other big things are things like how students' math scores or their grades in math and science and stuff like that. And the attitudes and their grades or performance on exams are highly linked together, right? So it's important not to totally think of them as being separate, because students with higher performance often have better attitudes about math. So some things that have been looked at before is I think my study is trying to dig deeper into and see nuance that there are different kinds of attitudes that students have in math and science. A lot of times, especially when these are analyzed statistically, it's just kind of motivational attitude about math, and it's maybe one variable or something like that. Also, a lot of the theory that expectancy value theory, for example, is a really popular motivational theory, and most of the research has been done on white middle class populations. That's why we need to find a better data source. And in 2009, the US funded a study by the National Center for Educational Statistics that is representative of the US as a whole, so has enough power to examine differences based on a lot of separate groups. So that's why I use this here. And also this data set focuses on pathways in and out of STEM. It started with ninth graders. It goes and has been following students all the way through college. And I'm focusing on the base year, which is the ninth grade year. And for students who are identified as Asian, Black, Hispanic, or Latino or white. So I'm not including every race group And because I also want to do an intersectional approach with gender and race, as we've kind of talked about, that already makes like 8 groups. And that's already a lot to do. So unfortunately, we can't look at every group we want to, but so I'm focusing on these groups here. The total cases is 21,000. So every group has at least 1,000 in it. So that's good. Okay, so what do I do? The methods here, so I want to compare STEM career aspirations and also these motivational attitudes towards math and science, and for certain well-represented groups and then other underrepresented groups. The attitudes I'm looking at, there's 4 different ones. It turns out to be 5, and they're both for math and science, so that ends up making 10 total different kinds of attitudes. That includes self-efficacy, identity, utility, interest, and cost, and I'll talk more about what those are. The students were grouped, some groups I looked at were high math achievers versus lower middle math achievers, low income versus middle and high income, first generation college students versus students whose parents have a college degree, and then also gender and race I looked at intersectionally. The stats methods I used here are the names of all this stuff, but I want to focus on the results. So we'll just get into that. You can ask me about all that stuff later, but that's the stuff I used, all those things there. Okay, so self-efficacy is basically like confidence. It's particular about like not just kind of like an overall confidence in yourself, but the confidence about that you can accomplish certain tasks in math and science class. So self-efficacy is like, I can do well in math and science. I believe in myself to do well enough, not like it's not an overall level. It's just, I can accomplish these goals if I worked out at it. Identity, this is kind of like the only quantitative study I actually know that looked at math and science identity. And this is how these are the 2 items they used. I see myself as a math person and others see me as a math person. And then also, for science, insert science where math is. So do you feel like you're a math person or science person? Interest is kind of like, do you like the math and science class you're in? Do you enjoy it? Is it not boring and you don't think it's a waste of time? So it's kind of like interest and enjoyment in your class, math or science class. Utility is math or science useful for college, a career, everyday life. There's 2 different cost variables that I ended up, just because of the statistics, kind of found that these are a little bit different. The first is like the time and effort cost. If I focused on math and science, I wouldn't have time for friends or I wouldn't have time for extracurricular activities. Like math and science is too difficult, take too much time to do well in. So it's costly in terms of like time. The last one here is a social cost, which we often think of as like, if I would be a nerd if I was good at math and science, right? So I wouldn't be popular. People would make fun of me if I was good at math and science. Okay, so those are all the different, these were all put together in composite scales using factor analysis. So first of all, here's a STEM career aspiration by different groups. So as you can see, students who perform highly in math are about twice more likely as students who don't perform highly in math to aspire to STEM careers. So this question asks students if they're interested in a STEM career by age 30. Like, do they think they'll be working in a STEM occupation by the time they're 30 years old? Now, for the underrepresented groups, like first low income, students from low income backgrounds are less likely to aspire to STEM careers, and as well as students who are first in their family's generation to complete a college degree. Overall, it's like about 8% of students aspire to STEM careers. So okay, so in terms of the intersection of race, ethnicity, and gender, as we can see, if you look at the blue ones are males. So we see that males are more likely than females to aspire to STEM in each 4 of these categories. Although the differences aren't always the same, right? So for example, in Hispanic and white groups, it's about the males are about twice as likely to aspire to STEM as females. But for Black students, it's actually female students are actually like only 1/3 as likely, or in other words, Black males are 3 times as likely to aspire to STEM. So that's as Black females. So that's the biggest difference in these categories.
Dalton, you have 2 minutes.
Okay. Okay, so let's get to some results here. Again, so here's this table, and it has a lot of stuff in there, but so that's why I made a graphic instead. So you know, what kind of students who have positive attitudes about math are more likely to major in STEM, or more likely to aspire to STEM. That's true. That's the red bars. We see the attitudes are more positive. It's also true for students who do well in math. For the most part, except for seeing math as useful. So there's in other words, there's a lot of students who do really well in math, but don't really think it's useful. You know, they probably don't end up majoring in STEM. Now, for low income and first generation college students, there are less positive attitudes about math and science compared to, you know, those respective groups. However, when it comes to usefulness of math, they actually see low-income students feel math is more useful than middle or high-income students. And same thing with first-generation students. I actually think math is more useful. And that actually ends up being true for science too. And also when we look by race, ethnicity, and gender, that also tends to be true. I think the biggest thing I notice here is that for underrepresented race or ethnic groups, the science identity is the biggest difference here. So Black, Hispanic students and white female students are the biggest difference is that they are less likely to to identify as a science person compared to white males. So that's the biggest difference here, but it's not there's actually some positive differences too. For example, Black students find science and math very useful, a lot more useful, about a half a standard deviation more than white males. So since I'm low on time, basically to answer this question, and are STEM underrepresented students less motivated in math and science? In some ways, yes. In other words, no. The biggest difference here has to do with science person. This is especially true for low-income students, first-generation college students, and Black and Hispanic girls. However, there are places where underrepresented students are actually more motivated in math and science. In particular, that has to do with math and science, finding it more useful. And then also girls tend to be less concerned with the social and time costs of doing well in math and science, which I think was actually maybe unexpected. I guess we usually think, I don't know, I don't know if there's too much research on this, but I think we often think like that girls would be more concerned with their image about, you know, being a nerd or not, but it looks like in terms of math or science, it's not the case with this data set. So yeah, so I hope that sort of like helped with this intersectional approach, and also kind of like this deficit and asset mindset that there are deficits, but there are also assets that we can leverage if we want to have better representation in STEM. Thank you.